Welcome to the physics class for November the 3rd. I know that some of you are 18 years old, so I really hope that if you haven't already voted, you will definitely go out later today and vote. Important thing to do, very important. Okay, before we get into the new material here, we've got several administrative things we need to talk about. Okay, so first off, the tests, I'm sure you've noticed that they've been graded, including the partial credit that you sent me. And for many of you, the fact that you sent me partial credit made quite a big difference in your grade. I mean, pulled you up one entire letter grade. So definitely sending me the partial credit was good. I had several people get perfect scores this time, so congratulations, way to go. Not just one this time, but several of you. I was definitely glad to see that. Now, it will be a required assignment this time, just like it was last time, that you redo the test problems. You may have already noticed that if you look on Canvas, there's an assignment in there that's labeled test rework. And the questions there are the exact same questions that were on the test. The difference is that this time around, you can try as many times as you want until you get a perfect score. And this time you are allowed to get help if you need it from another person. I would hope that you would only do that as a last resort, because all of these problems are problems that you really need to know how to do yourself. The stuff that we're doing today builds upon that stuff that we did then. And if the only way you can do it is with help, then that means you need to go back and work at it a little bit more. You should be able to do it without help. But hey, if you need help to do the test rework, it is not illegal to have people help you. If you are one of the people who got a perfect score on the test, I am not going to require you to redo it. I think you've earned your reward. What I will do is I will just I will go into Canvas and I'll just automatically give you credit, but only for the people that got a perfect score. If you're one of those people that got like 99%, sorry, 99 is not 100. And so you'll have to redo them. And by the way, you guys need to do all of them, not just the ones you missed, but you need to do all of them. I think that's a really good learning opportunity. Okay, now, although most people did very well, there were a fair number of people who didn't do quite so well. And so we need to figure out a way to get some help. I realize that because we're on Zoom, you don't have the normal peer assistance. You can't get together after school or during lunch and work on homework problems quite as easily. So I've talked with several people, and one idea that came up was to do a Zoom study room, or have several Zoom study rooms. And I think that that's an excellent idea. So I would hope that you guys would form your own Zoom study groups. In order to help you to do that, what I'd like you to do right now is I'd like you to type something in the chat box. Now, hang on until I tell you what it is that I want typed in the chat box. So if you are interested in doing a Zoom study group, which is optional, if you don't want to do it, that's okay. But if you're one of the people that would like to get together with some of your fellow students and do a Zoom study room, then I'd like you to type your email address into the chat box together with either the word yes or no. The word yes means that you would be willing to set up a Zoom room on your own. You guys know that Zoom is free. Now they have a free version and they have a paid version. With the free version, your meetings are limited to, I think, 45 minutes and a certain number of people. But hopefully that would be good enough. And so if you type in your email address together with the word yes, that means that you would be willing to be the host of a Zoom study room. If you type in your email address with the word no, that means that you want to be in a Zoom study group, but for whatever reason, you being the host wouldn't work out. So you're going to need somebody else to be the host. So go ahead and start typing that into the chat box now. I see some of you way ahead of me. Okay, good. So Connor, give us a yes or a no so we know whether you want to. Okay, thanks. Okay, so I'll let you guys keep on doing that. And in the morning class today, what somebody suggested was to set up a Google Doc where people could post their information there. And so you should be seeing it now on your screen there. Let me just, I'm not sure if the screen share went through, so let me do it one more time. Okay, so you should be seeing a Google Doc right now. That is what we set up this morning. So see, these are some of the people from the A3 class that wanted to do a Zoom study room. And so what I'm going to do is I'm going to copy this link into the chat box so that you can just click on it. Now you are going to have to request edit if you want to. You're going to have to request edit access if you want to put your name there. Lila Howells is the one who's running this. So if you click on request access there, she will let you in. So this way, if the people that you want to study with are not in this class, well, you can still get around it. Okay, so there, I've just posted the link there to Lila's Zoom doc or her Google Doc. So guys, try to set up your Zoom study rooms by yourselves. Now, I realize that there might be some people who, for whatever reason, don't get together with other students, but still want to be in a Zoom room. So after a day or two have passed, if you have not been able to link up with somebody else to form a Zoom study session, send me an email. And what I will do is I will assign people together to be in Zoom groups. But I would prefer that you work it out amongst yourself. That's first. Only go to me if it's a last resort. And one other thing, I'm going to try something experimental. I don't know if I'm going to like this or not, but I don't know until you try it. I am going to open up my Zoom room this evening from 7 until 9 so that you can do a Zoom study session there. And so you are all invited to join. Now, the fact that I have the Zoom room open, that it'll be my Zoom room, that doesn't mean that that I intend to be the person who answers all the questions. That is not my intention at all. This is for you to talk amongst yourselves and answer each other's questions. So I might poke my nose in every few minutes just to see how things are going and maybe answer a quick question or two. But for the most part, the intention is that you guys will ask each other questions. So this room that you're in right now, my Zoom room, it will be open from 7 until 9 tonight. And let's see how that goes. If people find that works and it's helpful, then what I'll do is I'll do it more frequently. And if I find that people aren't taking advantage of it, well, then I'll stop doing it. Okay. So hopefully that'll help those of you who didn't do quite so well on the last test, hopefully help you to do better next time. Now also, I'm sure that you know from your other Ames teachers that Principal Wilson has set up what he calls Zoom office hours. And it's every Friday morning from 9 until 10:30. And he's set this up for all teachers to have the same office hours. And the reason he did that is because at other times during the day on Friday, Mr. Wilson usually has various activities that he wants us teachers to participate in, teacher training and other things like that. So 9 to 10:30 is the time that we do that. Now, I have a unique problem in that the University of Utah physics class, which I co-teach, they meet on Fridays, even though the high school classes don't. But I only have to be there every other Friday. Now, it turns out this coming Friday is a day where I don't have to take care of the U of U class, so I will be there this coming Friday from 9 until 10:30, and I will be there where I will be active. I will be the one who answers the questions for the most part, but that's only on Friday. The Tuesday night thing is where I want you to answer each other's questions. So be there on Friday morning if you would like. Okay, a couple other things. Quizzes. Hopefully you guys remember last time I told you we're going to do quizzes a little differently this term because there needs to be some incentive to get you guys to take the quiz before the deadline. So the incentive is this. If you take the quiz and you get a perfect score on it before the deadline, then you get the perfect score. If you didn't get a perfect score and then you retake it after the deadline, which will be allowed, or if you just don't take it at all and only take it after the deadline, you will not be able to get a 10 out of 10. The best you can hope for is a 9 out of 10. In order to get that 9, you have to get a perfect score. So there is a penalty. It's only a 1-point penalty, so it's not worth losing a sleep over. But I need some sort of incentive to get you guys to take the test take the quizzes before the deadline. Now, I'm setting things up so that when you take that before the deadline, you will be given 2 attempts. So if you don't get a perfect score the first time, you can go in and Canvas will tell you which problems you missed. And so then you will be able to redo it, but you only get 2 tries at it before the deadline. And then what I'll do is a day or 2 after the deadline is passed, I'll unlock it so you can then go in and then you'll have unlimited tries. But then the best you can hope for is 9 out of 10. Okay, another thing, late passes. It's a new term, and so everybody has your late passes restored to you. You now all have 2 late passes again. Now, some of you didn't use your late passes last time, and you might be wondering, well, do the late passes roll over? Does that mean I now have 4 late passes? The answer is no. It doesn't work that way. Late passes don't roll over. So everybody now has 2 late passes again. And after you've used up your 2 late passes, I will not give credit for late homework. Now, quizzes are separate. You can redo quizzes all you want, no limit on the quizzes, except for the fact that you can only get 9 out of 10. But for homework, I'll only accept 2 late homework assignments. After that, you get 0s. Are there any questions about anything that I've talked about there? Not seeing anything, not hearing anything. Okay. Now, there is one other thing that we need to talk about before we jump into the new material. If you go to Canvas and you open up the extra credit opportunities, you'll see down at the bottom is a new one that wasn't there before. This is Engineering Day at the University of Utah. This is an event that they hold every year. And in fact, some of you, I'm sure, have attended this in previous years. The feedback that I've gotten from students about this has always been very positive. What they do up to the U is they open up their engineering labs and they have the professors there to tell you about what they're doing and answer any questions you have about what they're doing. And they do some really cool stuff up at the U. So if you click on the link here, it'll take you to a page that describes it. And of course, because of coronavirus, you find that they're having to do it a little differently this year. It's going to be held on Saturday, November the 21st. It runs from 9 until 1. But because of coronavirus, it's not an in-person event. It's going to be all virtual, all online. So I don't know exactly how they're going to do it, but presumably they're going to have different Zoom rooms set up where the professor will be there so that she can tell you what she does in her lab and hopefully show you the lab and the cool equipment. Registration is open. Now you might wonder, well, do you really need to register or can't you just show up on the day of the event? You show up online. And again, I don't know how they're working it, but I do know that in the past, they did have limited space because some of the labs up there aren't really large. And so you can't fit too many people in them. And so when people just showed up, they quite often were disappointed to find out that the lab that they were interested in seeing was fully booked. And so they had to go into another lab. So I don't know how they're going to do it this year, but you can see right here, they do have a button here that is a registration button, and they are encouraging you to register in advance. So I would recommend that you do that. I'm sure they'll have some incentive that will make you glad that you registered. So I will give extra credit if you attend this. And now you also have to write up a short description about what you did. You can't just tell me, hey, I attended it. You have to write up a page or maybe even a half a page, just describing what things did you participate in? You know, what were your thoughts about it? And if you do that, I'll give you credit that's equal to a homework assignment. And the neat thing is that this is separate from the normal limit that I put on my extra credit. You know how the most you can hope for from the normal extra credit is a third of a letter grade. Well, even if you've maxed out all of your normal extra credit, I will still give you credit for this. So definitely well worth doing. Okay, and so then we go back to the modules here. And let's start into the new material today. So if you go down to module 4, motion in 2 dimensions, this is today's homework assignment right here. If you click on it, it will tell you. So chapter 6 is what we're doing today. Problems 1 through 11 are the ones that are going to be due. But before you do the problems, obviously I want you to read the chapter, which is standard procedure. But here's a new thing. I've got an online Canon lab here, which some of you will recognize. And this online Canon lab is a tremendous tool to help you understand the homework that you're going to do today. So if you click on this link right here, it will take you to this. So remember back on the first day of school, I had all these virtual simulated physics labs, and everybody worked on different labs. And so some of you did a lab that was basically like this, where you took the cannon, you pointed it at different angles, and you shot to see how far the ball went, and you answered the questions that I had to ask. Well, today, everybody's going to do it. So let's just play with it for right now, and let's kind of get a feel for how things work. So first thing you'll notice is you can point the cannon at different angles, either up or down. Let's leave it horizontal for right now. You can also change the height of the cannon to any starting height you want up to 15 meters. You can also change the initial speed that the cannonball leaves the cannon at. Anything from 0 up to 30 meters per second is what you can do. So tell you what, let's have it be 20 meters per second. Let's start off right here. Let's go ahead and just shoot the cannonball, see what happens. Okay, bingo, that's where it lands. Okay, so let's take it up to 30 meters per second. Bingo, well, it goes off the screen there. Take it down to 10 meters per second. Okay, all right, shoot that. And I wonder what would happen if we take it all the way down to 0. Okay, let's try shooting it at 0. Ah, okay, it just falls. Okay, cool. But what interesting things could we learn from this? Well, let's grab this tool that you see right here and drag it in here. And so it's got this little like a magnifying glass here. If you position that so that it's on any of these dots, it will tell you the time, which means how many seconds after the ball was shot does this dot represent. The range, which means what is the horizontal distance that it has traveled in that time. And then the height, which is what is the vertical distance above the ground. So we got 0.4 seconds here. Here it goes to 0.5 seconds. So you can see that each one of these dots is 1/10 of a second, right? So let's pick this one right here. You see how this dot is a little different than the other dots. The other ones are closed dots. This one's an open dot. I wonder what that's all about. Well, if we put this on here, we see, okay, that's exactly 1 second. Okay, so we got 0.9, 1.1. Okay, so exactly 1 second after the cannonball was shot, it was 10 meters away, and it was at a height of 7.1. What if I look at the other trajectories and find out where was the ball 1 second after for each one of those? Okay, and especially the height, focus on the height. So notice the height here is 7.1. So if I come over here, hey, look at that. This cannonball, even though it was traveling faster, 1 second after it was launched, it was also 7.1 seconds above the ground. How about this one where we just dropped the cannonball instead of shooting it? Hey, look at that. it was also 7.1. Okay, so it looks like it doesn't matter how fast the cannonball is moving horizontally when it leaves the cannon. They all are going to be at the same height 1 second after they hit the after they were launched. And so I'm thinking it probably therefore follows that they would all hit the ground at the same time. So let's come down here and let's see. When did this one hit the ground? Okay, so it looks to me like it hit the ground 15, oh, that's the range. So 1.56 seconds after it launched, that's when it hit the ground. How about this guy here? Hey, 1.56. And this guy over here, I can't see it because it's off the scale. So let's change the magnification so now I can see it better. So this guy here, hey, yeah, 1.56. So they did all, in fact, hit the ground at the same time, even though they were traveling at very different speeds when they left the cannonball, when they left the cannon. Okay, that's really, really important information. That is something that's going to be vital in doing the first set of problems in tonight's homework. So let's do a problem like you're going to see in tonight's homework. Let's reset this and let's change this so it's at a different height. Let's put it, oh, let's say it's going to be at 8 meters. Okay, so I'm going to shoot the cannon at some speed here. How about, let's have it be 24 meters per second. All right, let's shoot the cannonball. Okay, so now in your homework tonight, they're going to ask you, how much time does it take before the cannonball that we just shot hits the ground? Okay, so I want to know this cannonball right here, what time was it when that cannonball hit the ground? Okay, now if you try to solve it by looking at this trajectory right here, you'll see that the path that it takes is what I like to call an evil path. The reason it's evil is because it's a curved path. It's a two-dimensional path. And we don't know how to deal with two-dimensional situations. If you go in and you look at all the equations that we worked with previously, the equations of motion, the ones that I like to call the Dr. Seuss equations, okay, those are all one-dimensional problems. Okay, they only work if you're moving in one dimension. And this problem here is a two-dimensional problem, so it's evil. So here's the way I propose we think about it. Let's have you guys seen movies where there's a good twin and an evil twin? You know, like maybe in Star Trek, Captain Kirk, he goes through the transporter, but there's a transporter malfunction. And so when it comes out the other side, there's two Kirks. There's an evil Kirk and a good Kirk. Okay, so we're going to think of it that way. We're going to think about this ball right here, the one that travels the evil path. That is the ball that was launched by the evil twin. And then we're going to have a good twin who's going to come in and help us. So if only we had a twin in the class here. Hey, Gia, do you know anybody who's twin? Well, the answer obviously is yes, Gia definitely knows somebody who's twin. So Gia, would you prefer to be the evil twin or would you like to be the good twin?
I'll be the good twin.
Okay, so Gia is going to be the good twin. So that means that Jonas is going to be the evil twin, although it could be Nevi as well. This is an interesting situation here. We got 3 that we can choose from. So let's say that Jonas is the evil twin. And so this is the ball that Jonas shot. And this is the ball that we are concerned about, is we want to know how much time it takes before Jonas's ball hits the ground. But because that's an evil problem, we need to call on the good twin to help us. So Gia is going to be the good twin. And the thing that makes her good, at least in this regard, is the fact that she only works in one dimension. So what Gia is going to do is she is going to shoot a cannonball, but maybe shoot isn't the best word, because what Gia is going to do is, so you see how I'm putting the speed down here at 0. So Gia is going to drop the cannonball at the same instant that Jonas shoots the cannonball. So let's see what happens with Gia's cannonball. There it goes, boom, okay? This, whoops, didn't mean to do that, sorry. Hate it when I do that. I forget that I have to turn on annotation before I touch my screen. Okay. All right, so this is the path that Gia's cannonball follows, and this is a good path. This is one we know how to deal with. That's one dimensional. And remember when we were playing with this before, what we found was that the ball that was dropped hit the ground at the same time as the ball that was shot, as long as the cannon was shot horizontally. In a few minutes, we're going to change that to where we don't shoot horizontally. But right now, we're shooting horizontally, and the two balls hit the ground at the same time. Okay. And so we know how to solve that. At least I hope you guys remember. I mean, it's been a little while, but it hadn't been that long. All right. So let's do it. So first thing you hopefully remember is let's make a list of all of the variables. So x naught, xf, v naught, vf, a, and t. Okay. Now, before we can put numbers in there, we need to make two decisions. One is where do we want to put the origin? And two is what direction do we want the plus direction to be? Okay, now most people like to put the origin wherever the ball was when we started the clock going. So that means the origin would be right up here. Now you don't have to do that. If you want to put the origin down here at the bottom, you can, and I promise you it'll work and you will get the same answer. But this is where most people like it. Okay, so that means by definition then, x naught is 0. Because what does x mean? X means how far away from the origin is the ball at any given time. So x naught means how far away from the origin is the ball when we start the clock or when we shoot the ball. And so if we define our origin to be up here, then by definition, x naught is 0. Okay, now this origin is 8 feet above the ground. So does that mean that xf is 8, or does that mean that xf is negative 8? Well, that depends on how we define our plus direction. Now, most people like the plus direction to be up, except for Sam. Sam likes it to be down, but we're gonna go with what most people like this time. Okay, so if the origin is up here, and when the ball hits the ground, it's below the origins, that's on the negative side of the origin, that means x final is not positive 8. X final is negative 8. Okay, now what is v naught? Okay, now some of you are going to say, well, v naught is the speed that Jonas shot the ball at. Ah, but Jonas is the evil twin. Okay, and we don't want well, I mean, although the evil ball is the ball that we're interested in, that's evil. So we need the good twin to help us out. So what is it that makes the good twin good? The fact that she only works in one dimension. So this initial velocity is the velocity of the ball that the good twin shot. So this is Gia's ball, okay? And so what Gia is doing is she just dropped the ball. She didn't shoot the ball. So the initial velocity that we're concerned about right now is going to be 0. Okay, what is x final? Well, every year I always have some students who say, well, if it hits the ground, then x final is going to be 0, duh. But hopefully you guys remember that's not the way it works. Okay, these equations only apply while the ball is in the air. As soon as the ball hits the ground, the equations no longer apply. Okay, so when we say v final, we don't mean after it hit the ground. We mean in that tiny fraction of an instant right before it hit the ground. So we don't know right off the top of our head what v final is. If we wanted to, I mean, it could be, we could calculate it. But right now we don't know what it is, and maybe if we're lucky, we don't need to know. Okay, how about the acceleration? So when Gia drops that ball, it's going to accelerate. Okay, what is it that's causing it to accelerate? Gravity. What's the acceleration due to gravity on the surface of the planet Earth? 9.8. But is it positive 9.8 or is it negative 9.8? This is what's really going to hurt you. If you guys If you guys are sloppy with this, you're going to get the wrong answer, and it's because of silly things like this. We decided that the plus direction was up. Gravity pulls down. So this A is not a positive 9.8, it's a negative 9.8. Okay, and then the last one is T, which is what we're looking for. So I like to put a box around it to remind myself that's what I was looking for. Okay, so hopefully you guys remember what the next step in the process is. We need to figure out which one of the equations of motion is what we want to use. So we need T. So clearly, whichever equation we pick, it darn well better have a T on it. Otherwise, it's not going to help us. And we don't know what V final is. So whichever equation we pick, it better not have a VF in it. Otherwise, we're going to have two unknowns and only one equation, and that's going to be a problem. So which one? Ah, very good. Yes, the mother of all motion equations. That is the one we want. Okay, so XF equals X naught plus V naught T plus 1/2 AT squared. Okay, I would hope that by now you guys have that one memorized, but I don't require you to memorize it. If you have that sheet that I gave you that has all the equations on it, I would recommend get that sheet out. You may have thrown it away thinking you're never going to use it again. Well, I got bad news for you. You are definitely going to be using it again and again and again. Okay, so we need to solve for T. All right, so we got a T here, and we've got another T over here, but this T is a T squared. So if you got a T and you got a T squared, sounds to me like a quadratic equation. Sounds to me like we need to use the quadratic formula, which we could do. We absolutely positively could do. But maybe we don't need to, because V initial is 0. So that means 0 times T is 0. So that goes away. And by the way, X naught is 0 too. So that goes away. So I'm thinking maybe we don't need to use the quadratic equation this time, although we certainly could if we wanted to. You absolutely could do it if you wanted to. But it looks to me like we got XF equals 1/2 AT squared. So we got a T squared and we don't have a T. So that means we can use the 9th grade method to solve this. And remember what I say when I say 9th grade method? I mean, take everything that's not T and get it on the other side of the equation. That's what I like to call the 9th grade method. Now, the 9th grade method does not work if you have both a T and a T squared. But in this case, we don't have the T, we only have the T squared. So the 9th grade method will work. So, okay, what are we going to do? Well, let's multiply both sides by 2. Divide by A and take the square root. Okay, so what we get then is T equals the square root of 2 times XF divided by A. And let me get rid of this thing there so it shows up a little better. Okay. All right. So when I get out my calculator, I do square root of 2 times XF, which, XF is a negative number. Ooh, take square root of negative number. That's bad news. How are we going to do that? Well, the A is also a negative number. So the two negatives are going to cancel each other out. Okay, so 2 times a negative 8 divided by a negative 9.8. So I get 1.277. Let's call it, let's say 1.28. Okay. I like to, that's more sig figs than we're legally allowed, but I like to carry a couple extra sig figs along. Okay, so 1.28, that is the answer for when Gia's cannonball is going to hit the ground. But what we really were interested in was when is Jonas's ball going to hit the ground? Well, hopefully you guys remember that as long as the cannon is pointed horizontally, the two balls will hit the ground at the same time. Okay, so then this is the answer for Jonas's ball as well. So let's do a little erasing here. Let's get out our nifty tool here. Where'd our tool go? Here it is. So let's see if that is in fact the answer. A little hard to tell there. Let's zoom out so we can get it. Okay, so hey, what do you know? 1.28, that is the right answer. And let's just go check over here on Gia's cannonball as well. Yep, okay. So it is exactly the same. So you see how this works is when you have a problem where you need to work with something that is evil because it's a two-dimensional problem, well, just call on the good twin. And the good twin is good because she works only in one dimension. And so if the good twin drops her ball, then the two will hit the ground at the same time. Okay, now, what if I'm not interested in knowing when the ball hits the ground, but what if I'm interested in knowing how far does Jonas's cannonball go? Well, again, you're thinking, well, that sounds like an evil problem, but maybe it's not so bad after all. Okay, maybe what we can do is we can take advantage of the fact that we now know how much time it takes before the cannonball hits the ground. Okay, and let's play with a feature here that we have not yet played with. If you look over on the right side here, you'll see we've got a couple of check boxes we can pick. So velocity vectors. Okay, let's click on velocity vectors and let's watch what happens here. So let's shoot the cannonball with the velocity vector on. Oops, that was Gia's. That wasn't what we wanted. Do you guys remember what the velocity was for Jonas's cannonball? I'll tell you what, let's just reset everything here. Okay, so let's say that Jonas shoots his cannonball at 20 meters per second. Okay, so let's see what happens there. Okay, now that went by so fast, it was hard to tell. Let's slow things down. You see there's a button down here that allows us to slow things down. Okay, let's try that again. Okay, interesting. And maybe let's see if we zoom. Oh, that's too much. No, can't zoom in that much. Okay, so we can see how the velocity vector is changing because the ball, it starts off going horizontally, but as it goes down, the velocity vector goes down like that. I am interested in looking at the components of the velocity vector. Let's see what that looks like. Okay, so let's shoot the ball again. Okay, now can you see the components there? Let's shoot it, and this time I'm going to stop it. Okay, and let's see if we can zoom in. All right, so if you look at the velocity vector there, boy, it's a little hard to tell still. Let's just stick with here. Okay, so we've got the actual velocity vector is the funky one. And if you look at the components, you can see we've got a horizontal component and we've got a vertical component. So the horizontal component is that one. The vertical component is that one. And so now let's step it forward a little bit in time here. So, okay, so now it's gone forward more. And now if you look at it, you can see that the vertical component is clearly much bigger than it used to be. But how about that horizontal component? It looks to me like it's the same as it was before. Let's step it through a little more. Let's see what happens. Let's step it a little bit more. There we go. Okay, all right. And now you can see that that vertical component is even bigger still, but that horizontal component is the same. The length of the horizontal component is not changing. Why is that? Can anybody unmute themselves here and explain why is it that the vertical component is changing, but the horizontal component is not?
Because gravity is an acceleration force.
And what direction is that force pointing?
Downward.
It points downward. Okay, so if we do a free body diagram of the ball when it's in the air, so let's just pick this point right here. All right, so I want a free body diagram. So we got mg pulling down. Now, what about air resistance? Okay, when the ball was right here, the velocity vector was pointing like that. Now that's a velocity vector, not a force vector, so I should do it in a different color. let's say, let's use this color right here. Okay, so the velocity vector looks like that. Now, you guys know that air resistance is basically like friction. It opposes the motion. So if the velocity vector is pointing in the direction I have drawn here, that means that the force of air resistance is going to be opposing that. Okay, so we got these two forces, and let me get rid of the velocity vector there because the velocity is not a vector, it's not a force. Okay, so at that instant right there, we have these two forces that are acting on the ball. So the air resistance should be slowing the ball down. Okay, but if you look over here, so you see where I'm circling right now, you see that there is a little checkbox there that allows us to account for air resistance, but this checkbox is not checked. So what that means is we are doing the simulation assuming that there is no air resistance, which is a darn good thing, because if we did include the air resistance, the mathematics would be really complex. Even those of you that are taking calculus right now, that's not enough math. You need to go to the next level above calculus. It's called differential equations. So if you include air resistance, the problem becomes one that you cannot solve using any high school techniques. And so what we're going to do then is we're going to ignore air resistance. And so the only force that's acting on the ball is a vertical force. There is no force acting horizontally. So of course, the horizontal component of velocity is not going to change because there's no reason why it should. The only component that's going to change is the vertical component. This is crucially important. Okay, if the horizontal component of velocity never changes, so actually tell you what, let's do here. Let's get a couple. Let's go back and clean this out. And so let's shoot the ball. I'd like it to be a little higher here. Let's shoot it from, say, 12 meters away, and let's shoot it at a speed of 20 meters per second. Okay, and so we'll go ahead and we'll shoot it once. Okay, there it goes. Now you see how the velocity vectors are changing. That's good. Okay, now I'm going to shoot it again, but this time I'm going to pause it periodically. All right, so here is the horizontal vector at that point. And that's all I'm interested in. Well, I'll draw the vertical one too, just for grins. Okay, so now I'm going to let it go a little bit further. Okay, there it is. Okay, and so again, you see the horizontal component never changed. Even though the vertical did, the horizontal component never changed. So if the horizontal component never changes, what we can do is we can say, let's assume that we have a third good twin, which normally we don't have three twins in this class, but luckily we do this time. We have a third twin we can call on. We can call on Nevi now. So remember, the ball here that's evil, that's the ball that Jonas shot. Okay, the ball that gets dropped vertically, that's the ball that Gia dropped. And so now, luckily, we have a third twin, and this third twin is Nevi. So what Nevi is going to do is she's going to get in a car, and she is going to drive her car, and she's going to drive her car at the same speed that the ball is traveling when it leaves the cannon, which the horizontal component never changes. So what that means is Nevi is going to drive her car at a constant speed that's equal to whatever the horizontal component is. And so what that means is that Nevi's car is always going to be directly underneath Jonas's ball, the Jonas's cannonball. Okay, so when Nevi's car gets to right here, Jonas's cannonball is right there. And so it's always going to be directly above her. And so right here, this is when the cannonball is going to go thunk on the top of Nevi's car. Okay, so Nevi is going to drive at constant speed. So we can just use D equals RT. If you're moving at constant speed, you don't need the Dr. Seuss equations. And so this rate is just whatever the horizontal component was, which is going to be equal to the 20 here. Okay. And then the time is whatever time it takes for Gia's cannonball to hit the ground. So you see how this works? Okay, so let's do this from the very beginning now. Okay, so let's say we start at 12 meters above the ground, and Jonas shoots his evil cannonball at an initial velocity of 20 meters per second. Okay, now that velocity changes. You can see when the velocity gets down here, the velocity is now greater than 20 meters per second. Okay, but we're interested in at the instant that he shot it. Okay, so if we want to know how far away from the tower did the evil cannonball hit the ground, we're going to have to call on our two good twins. So first, we're going to ask Gia to help us. So what Gia does is she drops a ball at the same time that Jonas shoots his cannonball. And so we know that x final equals x initial plus v initial t plus 1/2 at squared, but those guys are 0. And so what that means is that 2 times x final divided by a square root equals t. Okay, so if we put those in our numbers, or we put those in our calculator, so x final now is going to be a negative 12. G is going to be a negative 9.8. So what we get is that the time is 1.56 seconds. That's the time for Gia's cannonball. But hopefully now you guys all believe me when I tell you that is also the time for Jonas's evil cannonball. Okay, so now we know how long the ball is in the air. So now it's time to call on our third twin. Let's call on Nevi. And so what Nevi is going to do is she's going to get in a car, and she's going to drive a car, and she's going to leave at the exact same instant that Jonas shoots the cannonball. And she's going to travel at the exact same speed that Jonas shot the cannonball at. And she's going to travel at constant speed, so we can use D equals RT. So R is going to be 20. T is something that we didn't know before, but thanks to Gia, we do now know it. Okay, so let's just take 1.56 times 20. And so that tells us that the distance then is 31.3 meters. So that is how far Jonas's evil cannonball went. And if you doubt me, let's get out our little thing here, and let's put it here and measure it. And we can't see it very well, so let's change the zoom level. And so now we put it there, and what do you know? 31.3. Yay, it works. See how this works? Okay, so these are the kinds of problems that you're going to solve for the first set of problems, but it gets more interesting. Okay, what if the cannonball is not being shot horizontally? What if the cannonball is being shot off at a funky angle? Okay, so let's have it go off at a funky angle here. Let's have it be 30 degrees. Let's keep the speed at 20 meters per second. Let's keep the height at the height of the cannon at 12 meters. Okay, and so let's go ahead and shoot the ball here. Okay, let's see, why is it not going? Oh, because I need to activate that. Okay, so there goes the ball. You see how the velocity is changing? It goes as it goes along, and boom, it just hit the ground. Okay, so in some of your problems, what you're going to have to do is you're going to have to solve problems like this, where the question that you have to answer is how far away from the cannon base does Jonas's evil, and by the way, this is really evil now. Okay, so how far away from the base does the evil cannonball hit the ground? Well, we're going to solve this basically the same way that we did before, just with a little bit of a twist, but the fundamental approach is going to be the same. We're going to approach this in 2 steps. The first step is we're going to call on our first good twin, Gia, and she's going to help us to calculate how much time the cannonball is in the air. And then we're going to call on our second good twin, Nevi, and she's going to help us to know how far the cannonball went. Okay, now, when we did this before, Gia dropped the cannonball, whereas her evil twin brother, Jonas, shot the cannonball. Well, this time Gia is going to have to shoot the cannonball too. But what she's going to do is this. Okay, let's look at Jonas's evil cannonball at the moment that it gets shot. So if we look at the velocity vector, we see that the velocity is 20 meters per second, but it's off at a funky angle. And so we say, hey, well, hey, we know what to do with funky angles or funky vectors. We defunkify them. Okay, so we're going to break that up into a horizontal component and a vertical component. The vertical component is going to be 20 times the sine of theta, which in this case is 30 degrees. The horizontal component is going to be 20 times the cosine of theta, which is 30 degrees. So I propose to you that if Gia were to shoot a cannonball where the speed of her cannonball is equal to the vertical component of what her evil twin brother Jonas is doing, I propose that her cannonball will hit the ground at the same time that Jonas's cannonball does. Now, if you don't believe me, well, let's do a little bit of calculations here. Okay, 20 times the sine of 30. Anybody remember what the sine of 30 is? Hopefully you got that memorized. That's one that you should know from your math classes. What's the sine of 1/2? Okay, so 20 times the sine of 30 is just 20 times 1/2, which is 10. Okay, so I propose that if Gia were to shoot the cannon straight up with a velocity of 10, that her cannonball would always be at the same height as her evil twin brother. So let's see if that's the case. So let's take the cannon and let's point it straight up. Let's change the speed from 20 down to 10. And let's shoot the cannonball. And so there's the cannonball. It's going up, slowing down, it stopped. Now it's going down. And boom, it just hit the ground. Notice something interesting. Let me clear some space here in order to make it a little easier to notice what happened here. Notice that Gia's ball went to the exact same height that Jonas's ball did. And also, if we cheat a little bit and use our little measurement tool here, you'll find that Gia's ball hit the ground after 2.89 seconds, and Jonas's ball hit the ground after 2.89 seconds. So yes, it did work. Okay, so if Gia does her job right, then her ball will go to the same height. And when Jonas's cannonball is right here, Gia's cannonball will be here. When Jonas's cannonball hits the ground, Gia's cannonball will hit the ground. But it only works if Gia does her job right. Gia, in order to do her job right, what she needs to do is she needs to match the vertical component of what her evil brother is doing. Okay, now we were able to cheat here. We were able to use our nifty tool here to see how long it took for the cannonball to hit the ground. What if you don't have a nifty tool? What could we do if we had to calculate it ourselves? Well, remember that although the ball that we're really interested in is Jonas's evil cannonball, what we're going to do is we're going to do the calculations using his good twin, Gia. And so what we can do then is we can just approach this the same way we did before. We're going to make a list of all the variables, x naught, xf, v naught, vf, a, and t. Now we have to make the same decision that we had to make before. Where do we want to put our origin? So I'm going to be conformist again. I'm going to go ahead and put the origin up here. So that means x naught is 0. Okay. Now, how did our height get down to 10 meters? I thought I set the height at a higher number than that. So tell you what, let's change it because I don't want the height to be that. Let me clear this out. I want the height to be some different number. Okay. So, and actually this is advantageous. So now that we don't know now what the time is going to be in the air. Okay. So let's do this problem right. Let's start off. Let's put it at 30 degrees. Let's have Jonas shoot the ball at 20 meters per second. So there's the evil cannonball. And we're starting from a different height now. So we don't know how long the ball is going to be in the air. Okay. All right. So now Gia is going to step in. And so if the ball for Jonas was initially traveling at 20 meters per second, and this was, okay, so this is going to be 20 times the sine of 30, and this one here is going to be 20 times the cosine of 30. So this we know is equal to 10. Okay, so now G is going to step in and do her job. So what she's going to do is she's going to point the cannon straight up, and she's going to shoot it at 10, because 10 is the vertical component. Okay, so here comes Gia's cannonball. There it goes. Notice Gia's cannonball does in fact go to the same height that Jonas's cannonball goes to. Okay, now this time we need to calculate how much time the ball is in the air. So what we're going to do is we're going to make a list of all the variables here. So let me make some room here. So let's go with x naught, xf, b naught, bf, a and t. All right, so if we be conformist and we put our origin up there, that means x naught is 0. If we have our plus direction be up, that means x final is going to be negative 15. V naught this time is not going to be 0. This time around, V naught is going to be some other number. Here's a question for you. Should V naught be Jonas's speed or should it be Gia's speed? Should it be the evil twin or should it be the good twin? Well, answer is it should be the good twin. Okay, because this here is we're trying to solve the good problem. That's what makes the good problem good. Okay, so the initial velocity here is going to be Gia's velocity, which is 10. VF, we don't know, and if we're lucky, we don't need to know. A is going to be negative 9.8, and T is what we're looking for, so I put a box around that. Okay, so it's time to figure out which equation do we want. Well, it's going to be the same equation as before. It's going to be the mother of all motion equations. XF equals X naught plus V naught T plus 1/2 AT squared. This time T is not, or I'm sorry, V naught. Okay, the T does not go away because V naught is not 0. Okay, so what that means is this time we've got a T and we've also got a T squared. So that means that this time we cannot use the 9th grade method. We can't just say, take everything that's not T and get it on the other side of the equal sign. That is not going to work for us this time. This time we have to use the quadratic formula. We have no choice. But that's okay. Hopefully you've got the quadratic formula programmed in your calculators like I warned you to. Okay, so let's put in the numbers. So X naught is negative 15. Or I'm sorry, XF is negative 15. X naught is 0. So V naught is 10 times T plus 1/2 times negative 9.8 times T squared. Okay, now, before you can use the quadratic formula, don't forget it. You have to rearrange it so it equals 0. Otherwise, it doesn't work. So that means we have to add 15 to each side. So what we're going to get then is 0 equals 15 plus 10 times t plus, I hope you guys are okay if I combine those two together. So I'm going to take, instead of being a plus there, that's going to become a minus 4.9 times t squared. Okay, there you go. So have you guys got this programmed in your calculators? If not, shame on you. I warned you to. Get it in there. So if you look on Canvas, there in the resources section of Canvas, I've got a video that tells you how to do that if you've got a TI 83 or 84. And I've got a separate video that tells you how to do it if you got a TI Inspire. And also, we can, if we don't have one of those two calculators, there is actually a third way. If we click on a new web browser page and we type in Quadratic Formula Calculator, okay, hit enter, you'll see that on Google, the very first thing that comes up here is and it's hard to see because I got so much writing on the screen here, but the very first hit is something to our website called Calculator Soup. So if we click on that, it takes us to a web page right here. And so I clearly need to get rid of some stuff where we can see better what's going on here. Okay. All right. So here's a web page that will solve the quadratic equation for us. All right. So all we have to do now is just type in the numbers. So now A, be careful with this, guys. A lot of people get this mixed up. A is not the first number there. Okay, A is the coefficient of the x squared term, which for us is the t squared. So A is negative 4.9. So be careful about that. So let's type in A is negative 4.9. B is 10. C is 15. Now we type on calculate, give it a couple seconds there, and bingo, there is the answer. Okay, now you'll notice there's two of them. Okay, so one of the answers here is negative. So clearly that's not the one we want. That's what we call an extraneous solution. All right, so 3.0458. So let's call that, just call it 9. Actually, okay, let's just call it 9. So this then is the time that the ball is in the air. Okay, so let me write that down. So 3.049. Now let's clear all this out. Okay. All right, so Gia has done her job. Gia has allowed us to calculate that her cannonball is going to be in the air for a time of 3.0, that's a 3, look like it. 3.049 seconds. And that means that that is also how much time her evil twins cannonball is going to be in the air. Okay. All right, so now that we finished that, now we're ready to go on to the next step, which is let's call in our third twin. Let's call in Nevi. And so Nevi's job is to get in a car, and she is going to drive that car at constant speed. Now, if Nevi does her job right, her ball will always be directly beneath Jonas's cannonball. And so when Nevi gets right here, that's when Jonas's cannonball will go thunk on top of her car. But it's only going to work if Nevi does her job right. Now, what does it mean for her to do her job right? Well, kind of like it was with Gia, what she needs to do is she needs to match the vertical component. No, horizontal this time around, sorry. Okay, Gia was the vertical twin, Nevi is the horizontal twin. Okay, so if we draw the initial velocity vector of the real cannonball, so 20, okay, at an angle of 30. So the horizontal component here is 20 times the cosine of 30. That is the component that never changes. At any point here, if you draw the velocity vector and defunctify it, you'll find out that the horizontal component never changes. So that's the speed that Gia needs to drive her car at. So when we are doing the equation for Gia, we can just use distance equals rate times time because she's moving at constant speed. So 20 times the cosine of 30, that's the rate. And then the time is the number that we got from Gia. Maybe I'm getting my Gias and my Nevis mixed up here. But anyway, so if I take 3.049 times the cosine, times 20 times the cosine of 30. Okay, let me make sure I didn't enter it wrong there. Okay, so that tells me 52.8. That is the distance that Jonas's cannonball is going to go. Let's see if that works. Let's cheat. Now that we've done the math, let's pull out our little measurement tool here. Let us put it there and see. Hey, look at that, 52.7. So round off error. Don't worry about round off error there. Okay, so to within round off error, bingo, we got the right answer. So you guys see how this works? Any questions? I've been doing a lot of talking and I haven't looked in here. Okay, and I don't see any questions. Okay, now let me just give you one more problem like you might see tonight. It's actually, let's just take this exact same problem. What if the problem isn't interested in how far did the ball go, but what if the problem is interested in how high? What is H max? Okay, what's the highest point that Jonas's evil cannonball is going to reach? Well, again, because this is an evil problem, we can't do evil problems. We can only do good problems. So we're going to have to call on the good twin. And so Gia is the vertical good twin. So if Gia does her job right, her cannonball will go to the exact same height that, that Jonas's cannonball goes to. Okay, so all we have to do is just figure out how high will Gia's cannonball go, and bingo, we're in good shape. So let's make a list of all the variables. Okay, so X naught, XF, V naught, VF, A, and T. Okay, and again, let's be traditionalists and let's let X naught be at the origin, so X naught is 0. This time, XF is not down here. Okay, this time we are interested in going, we want to know how high does the thing go. So XF is going to be this guy up here. So that's what we're looking for. So that's now a question mark. And let's put a box around that. V initial, remember, is not the evil velocity. It's the good velocity. It's the vertical component of the evil velocity. So it's going to be 20 times the sine of 10 degrees. I'm sorry, 20 times the sine of 30 degrees, which we now know is 10. V final, what is V final going to be? At the top here. Well, we know that when it reaches the top, the ball is going to stop. So V final is going to be 0. What's the acceleration? Negative 9.8. What is the time? We don't know. Okay, so which of our Dr. Seuss equations are we going to use here? We need an equation that's got an X final in it and does not have a T in it. Which equation is going to do the job for us? How about if we use the VF squared equation? So VF squared equals V naught squared plus 2A delta X. All right, yes, that is the one that we're going to use. Okay, so let me make a little room here because I'm going to need to do some writing there. Okay, All right, so what do we do? Well, we're trying to solve for delta x. So let's get that v naught squared over on the other side. So vf squared minus v naught squared divided by 2a equals delta x. Okay, and then plug in the numbers, and I don't need to do this, right? I mean, you guys can do it from this point on. All right, and so that'll tell us how high Gia's ball goes, which will be the same as how high her evil twin Jonah's cannonball goes. Okay, so I understand that that was an awful lot to hit you with. So let me just recommend that you go in and you play with this cannonball thing. This cannonball thing is a wonderful, wonderful tool. Play with it a lot, but be careful to make sure you've always got the air resistance off, because let's take a look at it. Let's see what happens. What if we don't do it right? What if we accidentally turn on the air resistance? Let's try shooting the ball there and let's see what happens there. Whoa, hey, look at that. You can see it's making a big difference, okay? If we include air resistance, that is going to screw everything up. So when you guys play with this, make sure that you have the air resistance turned off. Otherwise, the numbers you get are going to be all screwed up. Okay, so Sam is saying, why don't we just banish the evil twin? That's a good idea. Hey, Gia, would your mom be okay if we just banished your brother? Do you think your mom would be okay with that? Yeah, actually, let me ask that differently.
Good of him, you know, easy.
Would you be okay with it? Oh, yeah, Gia is enthusiastically in favor of that.
Oh my gosh, no, I don't want to get rid of Jonas.
You like Jonas?
Yeah.
Well, yeah, he's a nice guy. Okay, I can understand that. Okay, so are there any questions before you guys type bye into the chat box? If not, you can just say goodbye and I'll see you next time. If you have any questions, tell you what I'll do is I'll turn off the recording so that if you have a question you didn't want to ask because you didn't want it to be recorded, let's fix that.